today, if you go to the agenda, you will see that there is an assignment. It says it's a project, but it's actually a lab more than a project. Okay, you're going to be building DNA molecules. Okay, so if you are a person who has a packet, you are just going to wait a minute while I explain how the people who do not have a packet will build their DNA molecules. Packet people, you're going to build this molecule that I have right here. Okay, so there are two different assignments. There's an assignment for those with a packet. There's an assignment for those who do not have a packet. Okay, they're worth different amounts of points. So the one with the packet is worth a little bit more points than the one that is virtual, because you have to do more work if you have the packet. Okay, so if you are a person who is, who does not have the packet, you're going to click on the agenda, number 2, building a double helix mini project virtual version. Okay, once you click, you'll see a set of instructions. Step 1 is not for you. Step 1 is for the people who have the packet. So if you do not have a packet, you're going to go to the bottom underneath the instructions, and it says you're going to complete the assignment using the DNA Gizmos activity. It's already assigned to your class. Here is your class code. Every class will have a different code. So this is the code for 4th Bell. Make sure you join the correct class. You have to go in and check your code. Remember, I'm recording this for other people too. Okay, so you're going to go to Gizmos, and unfortunately, if you are locked out, I do not have access to your passwords right now like I normally do, so you'll have to make a new account. That's the best I can do. Okay, so if you do not have a packet, you're going to build your DNA molecule on Gizmos. So the assignment on Gizmos begins with just a blank nucleus. This is a nucleus. Before I explain what to do, I want to ask a question. What is a nucleotide made of? Anyone know what a nucleotide is made of? This is something else that's been in multiple assignments. Markayas, do you know? Sorry. Markayas, do you know? You usually know. Yes, sugar, William. What else? Phosphate groups. And what else? Nitrogen bases. All right, William and Markayas are the dream team. Okay, so they are made of sugar, phosphate groups, and nitrogen bases together. If you look at the gizmo, you'll see that they only have sugar and a base on this part up here. Okay, and if we're going to build DNA, we also need phosphates. They're down at the bottom. When you only have a sugar and a base, it's called a nucleoside and not a nucleotide. So these are the nucleosides. They are made of a sugar and a base. We have to add the phosphates. Okay, so to build my DNA molecule, I can put my things in any order. So I'm going to build it one side at a time. Okay, so I think I'll start with a G. I need to add a phosphate at the top. Uh-oh, how will it not let me do it? Okay, I'm going to add it at the bottom first and then see if it lets me. It won't let me add it at the top. I think it's going to make me do it at the end. Okay, so I've got a G. Let's see. I think I'm going to go in with the A next. I'm going to add my next phosphate. I think I'll do another C. I think I'll do a C. I'm going to add a phosphate. Oh, let me add my phosphate at the top now. So don't forget this phosphate at the top. This is called your leading strand that you're making. The strand on the left is the leading strand. It always has a phosphate at the top. Okay, let's see. I think I'm going to do a T now. And I'm going to add my phosphate. I'll do a C. I'm going to add my phosphate. I'm going to do a G, add my phosphate. A, add my phosphate. And then finally, I'm going to do a T. So I've done one side of my DNA molecule. Now I have to base pair to make my second side. So I have a G. So what base will I put next to the G? A C. And I'm going to add a phosphate. Now this is called the lagging strand that you're making. So the leading strand and the lagging strand. The lagging strand does not have a phosphate at the top. It has a phosphate at the bottom. So instead of putting a phosphate up here like you did for the leading strand, your lagging strand has it on the bottom down here. Okay. So after you build your whole DNA molecule out and you do all your base pairing, you're going to click the camera and take a picture. You want to save this picture and you're going to submit it with your assignment. You have 2 things to submit with your assignment. Okay. So that was for the people who do not have a packet. If you do have a packet, you are going to do yours is probably a little more fun because you get to actually build it with paper. Okay, so people who are doing it virtually, just hold up for a minute and I'll go through steps 2 and 3 after I tell the people with packets how they're going to build their DNA. So I'm projecting my picture. It looks upside down and I apologize about that. So what do you notice about my DNA molecule? What stands out to you? Okay, it's colored. You will color yours in. And you get to pick whatever color you would like, colors you would like. Does anything else stand out about it to you? Anything else stand out? Look at my sides. What stands out about the sides of the DNA molecule? Excuse this paint on my desk. What stands out about the sides? One of them is upside down. Yes, that is called anti-parallel. DNA is actually anti-parallel. That's something we didn't see on the gizmo. So one strand is upside down. So you have a strand going the right way and a strand going the wrong way. So you have your leading strand going the right way, and then you have your lagging strand that's backwards. The phosphate, the extra phosphate is on the bottom. See? That extra phosphate that's on the top normally is on the bottom. Okay. So you are going to, there are 7 pages of pieces in your packet. You're going to rip them out. You do not need to color all 7 pages. I gave you a lot of extra. Your DNA molecule is going to be the same size as mine. You don't need to build a big, long DNA molecule. Okay. So you can rip your pages out and click on Building a Double Helix Mini Project. You are going to follow the instructions where it says step 1. The first thing you'll do is color all of your pieces. And each type of piece should be a different color, but you can pick your colors. If you want to copy mine, that's fine. But you don't have to. You might want to make your thymine brown and your adenine orange. You can do that. It's up to you. Okay. So after you do your coloring, you're going to cut them out. I'm going to tell you how many you need of each piece. You need 10 deoxyribose sugars. You need 10 of the sugars. You need 10 of the phosphate. And then you're going to need a total of 10 bases. Now, your bases, it will depend on how you want your molecule to look. I chose to use 4 adenine and 4 thymine. That gave me 8. And then I chose to use 1 cytosine and 1 guanine. You don't have to do that. You can pick whatever order you want your bases to go in and however many you would like to use. It's up to you. Okay? So you pick. So once you have colored and cut your pieces, you're going to lay them out just like this. And I know mine looks really weird, but remember, it's a phosphate, a sugar, a phosphate, a sugar, a phosphate, a sugar, a phosphate, a sugar. And they have little shapes on them. You actually are going to match the shapes. So you're going to match the stars together. You'll match the squares together. And you'll match the circles. Okay, so there are, if you look at your pieces, you'll see that they have shapes and you're just going to match the shapes. Okay, once you've laid it out and you're satisfied with it, you can glue it together. You're going to take a picture of it and you're going to upload it onto Echo. Okay, now I'm ready to tell everyone what they'll do for steps 2 and 3. So everyone's going to build a DNA. It will depend on if you have a packet, how you build it. Okay. So if you have a packet, you're building it out of paper. Okay. And yes, you'll get a few more points because this is a little harder. If you do not have a packet, that's okay. You're not going to lose points. You're not in trouble. You're just going to do yours virtually. It's no big deal. Okay. Step 2 for everybody is going to be to click on the structure of DNA writing link that's on the instructions. And now I have to share this tab. You're going to click on the structure of DNA writing. And you are going to answer the 7 questions. Okay? They're not necessarily going to be long answers. I'm not looking for paragraphs here. Okay, I just want you to answer the questions that are asked. I gave you some vocabulary words at the top that you can use to answer the questions. Okay, so you've got vocabulary hints at the top to answer the 7 questions. This part shouldn't take you long. Okay, this should be the easy part because we've done these questions before. All right. They came from your POGL. They came from the Ed puzzle. They came from your notes. After you answer the question, you have one more step because I need some oral communication from you guys. I need to give you an oral communication grade. What you will do is you're going to turn your questions in on Echo, but you're also going to record your answers on Flipgrid because I just love to hear you guys talk about science. Okay, so you're going to go down to the bottom and click the link that says Flipgrid. And all you will do is just record your answers to the question. Number 1, the question is blank, tell the question and then your answer. Okay, make sure that you're speaking clearly and slowly. Speak loud enough that I can hear you. Look at the camera when you're speaking. Please don't use any stickers to cover your face, but you can use a frame. Practice and do your best work. This video will only be seen by either me or Miss Bazanka if you're one of her students. Your fellow peers will not be able to see your video because it's set on private. Okay, so don't worry about someone seeing this. I would never share your likeness, your face with anyone without your permission or your parents' permission. If your video is really good and I would like to use it for next year's class, I will ask you for your permission. Okay. So that's the end of the lab. You're just making your DNA, you're answering the questions, and you're recording your answer on Flipgrid. This is due on Sunday night, but you have until Monday night to get it done. So Monday in class, when we, I'm sorry, we don't have class, but Monday we have those meetings. So if you want to schedule a meeting with me, you can. If you want to go over your project or your lab. Any questions that I can answer? Any questions? Okay, if there are no questions, you guys can go ahead and start. I'll be here. I'm going to leave this up right here. And I'm going to put my Gizmo DNA on the screen so you guys can see it while you work. Please ask any questions you have. Don't ever feel embarrassed or feel like it's a dumb question, because somebody else probably has that same question and they're glad you asked. Okay, so please ask me. This is not meant to be stressful. It should be fun. And it's not meant to be very difficult. So if it seems like it's really hard, then you probably need to get clarification. Okay.